Okay, these are the notes for angle side angle and angle side congruence. We have an angle side theorem or angle side angle theorem, which if you look at the diagram, if you have two angles in an included side that match or are congruent between two triangles, then those triangles must be congruent to each other. So in a normal congruence, all the angles need to be congruent and all the sides need to be congruent. So there's like 6 congruences. But if you can come up with a pattern of angle side angle, that's enough to force that all the other parts are congruent also. So that's a congruent shortcut by having those 3. So I'm showing here, A matches with D, side AB matches with side DE, and angle B matches with the other angle, so that gives us angle side angle. Another congruent shortcut is angle angle side pattern. So if you have 2 consecutive angles and the very next side, then that is enough to know that those 2 triangles are going to be congruent because all the other parts have to be congruent. So in looking at the examples here, we got a right angle there that gives us an A. We've got angle A and angle E congruent, that gives us another A. And then we have side CD congruent to side CB. So we have angle, angle, side pattern. E to C to the CD side is angle, angle, side. So those triangles are going to be congruent. Looking at number 2, we've got an angle, another angle, and the side that connects those 2 angles together, the included side. So that gives us an angle side angle pattern to show that those 2 triangles are congruent. So these are congruent shortcuts. All it takes is 3 to basically know that all 6 parts are congruent. So here they're giving us angle side angle proof. So if we look at what's going on with this, BAC is congruent to DEC, so those 2 are congruent. The BD bisects AE, so that means that those 2 segments are going to be congruent. And then we have the vertical angles at C that are going to be congruent to each other. And so AC is congruent to CE, and then the 2 vertical angles, that gives us an angle side angle pattern to know that those triangles are congruent. And you can see the 5 steps worked out in the proof. Let's look at number 3. Number 3, you got a couple of overlapping triangles. Sometimes it's useful to draw those separate from each other to make it more straightforward. But we've got the angle at A and the angle at E are congruent, and we also have that DC and BC are congruent. And the angle C is common between both of those, so we have an angle side angle pattern that we're going to use to prove that congruence. So we're putting our givens in. DAC is congruent to angle BEC, and also side DC is congruent to side BC. Those are the givens. And then angle C is congruent to itself by the reflexive property. And if we look at the pattern in the triangles, we have ASA, and the ASA pattern is enough to show or guarantee that those 2 triangles are congruent. And I need to make name the congruence the right way. So triangle ACD is congruent to triangle ECB. Let's look at number 4. Number 4, we got the 2 right angles. Those are going to be congruent. We got the sides. That gives us the S pattern. And then the vertical angles in the center gives us an ASA pattern. So we can say that those 2 triangles are congruent by angle side angle. Looking at number 5, we've got an angle and an angle, and then that side up the middle is congruent to itself by the reflexive property. So that gives us an angle side pattern also. So those 2 triangles can be proved congruent by angle side.